guys, welcome to another video for anatomy and physiology. In this video, we're going to be highlighting connective tissue. Connective tissue, that's the operative term there, the connective. We're looking at tissue, the different types of tissues that basically keep the entire human body together. So, for example, if I was looking at a house and I was thinking about the things that comprise a house, that keep it together, there are many things that make a house what it is. For example, you can talk about the cement that forms the base. You can talk about the mortar between the bricks that keeps the bricks together that form a wall. You can talk about the studs, the wood framing inside of the house that gives shape to the house. You can talk about the nails that keep the studs together, and then the sheetrock and even the paint that goes on the walls provides some structural integrity to the building. So, like I said, we're talking about the human body and the connective tissue. So these are all things that comprise the human body that keep it connected and that allow cells to connect with each other, communicate with each other, and that gives the body structure, much like I said, all the building materials in a house. So cells don't usually come in contact with each other, and as we look at the slides, the different number of slides that we're going to be seeing here, you're going to notice that the cells are typically, they can be either evenly spaced out. If you go back to the cells, the different types of epithelial cells that we have, sometimes the nuclei are aligned or sometimes they are not. And likewise with connective tissue, the cells for the most part are scattered randomly. And they're separated by a matrix. So, when you look out in the starry sky, you see, you see stars, but then you see a lot of empty space in between the stars. Likewise, when you look at the cells and the different tissues that are running through it, like nerves or blood cells, you'll see that there's mostly a lot of, it's not empty space, but it's space. It'll look like empty space, but it's actually something called a ground substance. And that ground substance is a protective substance. It absorbs compression, and it protects delicate cells that are embedded inside of the tissue. Okay, so again, we're talking about the things that keep the body intact. Likewise, with the mortar that goes in between bricks, that gives the walls strength and it gives it shape. Likewise, so does this ground substance. Or maybe you can think of Jello. If you ever put like fruit inside of Jello, the fruit in the Jello could be like the cells, and the Jello itself is the ground substance. Okay, so there's 8 functions for connective tissue. And we're not going to go through each of these right now necessarily, but as we go through the slides, we will touch on these particular functions of the connective tissue. So let me just go ahead and read them off here. We bind organs, you support body tissues, it's physical protection, immune protection, movement, storage, heat production, and transport. Okay, there's a few things in here, a few connective tissues that you may not have thought originally. If I were to ask you to make a list of tissues that you would think of as connective tissues, blood would probably not be one that you would put in. But blood is very much a connective tissue. Now, we're not going to get very much in depth into blood in this particular chapter because there's a whole chapter dedicated to blood, but we do kind of talk about its connective properties in the sense that blood kind of connects everything together in the body, and it helps to transport nutrients and heat throughout the body. So these different types of connective tissue vary greatly in vascularity. Okay, so they vary greatly in their density and their lack of density, their looseness, if you will. And like I said, as we go along, you'll see what I'm talking about here. So some of them that have a lot of vascularity, they'll have rich networks of blood, and this is in loose connective tissue. Okay, so pay really close attention to the names of these tissues because they will, I think they will save you a lot of time in studying. Because if you understand the name, then you kind of it kind of helps you. It leads you into what the function or the purpose of this particular type of tissue. So you have loose connective tissue, which is very loose. Okay, think of wearing like a loose T-shirt. You have a lot of space in that T-shirt for stuff. You can stuff a balloon. You can stuff, I don't know, a shirt or a whatever. So there's a lot of space, a lot loose connective tissue. A lot of space for nerves, for blood vessels, Now, there are some connective tissue that have no blood vessels. Okay, so they have low they have low resources in the form of nutrients. An example of that would be cartilage. Cartilage, for example, in your ankle. If you've ever wondered why it takes so long for your ankle to heal, it's because cartilage has very low blood vessels. So that means waste products can't leave, and nutrients take a long time to get there. So when you damage cartilage, it takes a while for it to heal because of its lack of blood vessels. So let's take a quick look at the 5 types of connective tissue. The first one, like I said earlier, is loose connective tissue. So here's a slide of the loose connective tissue. Some of the things that we have here are the ground substance, like I mentioned before, and that's mainly like the white that you see. Okay. Now, technically, the ground substance has been taken out of this particular slide, but the space where you see nothing, like where it's all white, that's where the ground substance would be. That would be the filler. Okay. And then you have elastic fibers that allow the tissue to be stretched. Okay. Collagenous fibers and fibroblast. Anytime you see the suffix blast, that is referring to a cell that produces or that makes that thing. Okay, so for example, this particular slide is a slide of areolar tissue. This is called areolar tissue. Areolar tissue is made by fibroblasts. So again, the microscopic appearance for this particular slide, you have a loose arrangement of collagenous fibers, elastic fibers. You can see they're kind of all randomly placed around. You have scattered cells of various types and an abundance of ground substance. And then you have numerous blood tissues, blood vessels that are going through it. Again, this tissue heals fast and it processes nutrients very quickly. Okay. Now, some of the areas where you would find loose connective tissue, you actually find it all over the body. It's underlying all epithelium. If you go back to the epithelial lectures, you'll see that when you have the like squamous cell, simple squamous or simple cuboidal, underneath those cells, you'll see the ground substance just below it. Okay, so again, this is found basically all over the body. Okay, so it surrounds blood vessels, it surrounds nerves, the esophagus, the trachea, the fascia of muscle, the pericardium of the heart. So it's all over the place, the pleura and the lungs. So it loosely binds epithelial to deeper tissue. So it's kind of like a cement, if you will. It's a binding agent. It allows passages for nerves, blood vessels, and other tissues to go through it. It provides an area for immune system defenses. So your immune system can go through there. It's kind of like if you're at a concert, imagine like police officers walking through the crowd. You know, that's kind of what we're looking at here. And the more spaced out the crowd is, the better the immune system can go through there and find any foreign pathogens. Okay, so that's loose connective tissue. Now there's another type of loose connective tissue. This one's a little bit tougher, and as you can tell, it's quite different than the areolar tissue. This type of loose connective tissue is called reticular tissue. So the microscopic appearance of this, you have loose connective reticular fibers of the cells, and it's infiltrated by leukocytes and lymphocytes. And the leukocytes and lymphocytes, now in the areolar, you have immune system properties, or the immune system can kind of go through it. Here, it's a heavier presence, if you will. Try to, so we mentioned a concert for areolar tissue, right? Well, with reticular tissue, imagine the president coming by. Well, when the president is in town, you're going to have a lot more security. I remember when I was in Seattle and President Obama landed like 100 yards from the school that I was at. I mean, there was police, SWAT everywhere. And in fact, there were even helicopters circling around with snipers. And when he showed up on the university next to the school, there was actually 3 Air Force One helicopters that showed up, but only one of them had the president. And I understand that the 3 helicopters were in case there was ever, an attack or something, that they would know which one the president was in. So in any case, so my point is that there's a lot more security, if you will. And in reticular tissue, there's a lot more immune system presence here. And then when you consider where it's located in the lymph nodes, which deals a lot with the immune system, the spleen, the thymus, and bone marrow. So your immune system essentially originates and is housed in these areas. This is like their police station, if you will. So it makes sense that there's a lot of lymphocytes and leukocytes that are present in reticular tissue. Okay, so it also supports stromal framework of lymphatic organs. Okay, so this is like the this is like the like the framing of a house, if you will. It creates the structure. Okay, now the last type of connective tissue we have here is adipose tissue. So adipose tissue, you'll see here some of the things that, some of the microscopic appearance of this, it's dominated by adipocytes. Okay, adipocytes are basically cells that contain adipose tissue, which is fatty tissue. Okay, so they're large, empty-looking cells with thin margins. So you can kind of see that they have fairly thin walls there, and you have shrunken nuclei that are pressed against these walls. You can see that they're like kind of dark purplish in each slide here. All right, so you're going to have to go through each of these types of slides, and I'm going to show you a slide, and you're going to have to be able to identify the different features and the name of the slide and where it's located. So some of the locations for adipose tissue is, like I said, it contains fatty tissue, so you can kind of imagine where it might be located. It's beneath the skin, okay, in the breast, around the heart, okay, the surface of the heart, your internal organs, like even behind your eyes, there's fatty tissue. Anywhere where there might be where there's cushion that's needed, anything that's vital, like your heart, your lungs, and all of your organs on the inside, it is impossible to get rid of all the fat in your body. You probably die, because your body needs, you could have a six-pack and you could be shredded and everything, but you're still going to have fat in the body, because that's the cushioning of your internal organs. And this adipose tissue is the tissue that surrounds those organs. And if you can see here, that looks like it's a blood vessel, some kind of vessel that's being surrounded by that adipose tissue. So we're looking now at dense connective tissue. So this is the second type of connective tissue. And dense connective tissue, like loose connective tissue, has two different types. We have the regular dense connective tissue, and you can see the collagen fibers. If you just picture like a river running through a forest or whatever, and the water, the waves that you see in the water. So this is kind of what you're looking at. You're looking at this very densely packed collagenous fibers that are in a wave-like pattern, and then you can kind of see the nuclei kind of squeezed in there, in between the pattern, in between the collagenous fibers. Oops, let me back up. I wasn't actually done with that yet. So, and also you'll notice that, like, unlike the loose connective tissue, there's not a lot of open space. There's not a lot of ground substance. So because these connective fibers are so densely packed, that means that they're also very strong. Okay, so just imagine a rope. If you've ever kind of cut open a rope, the rope has a lot of tiny little fibers, and they're tightly packed. In fact, if you squeeze it hard enough, you can kind of hear it like really tighten up. And because of this density of this material, there's not a lot of space for blood vessels. Okay, now if you kind of remember from earlier, when you don't have a lot of blood vessels, you don't have a lot of nerve endings, you don't have the ability to heal as fast. So these types of connective tissues, you're going to find mainly, these are mainly ligaments. In fact, some textbooks will call this white connective tissue, because when you dissect an organism and you look at the dense connective tissue, it's like a shiny white, silverish, dense tissue. Okay, so this tightly binds bones together, and it resists stress, and it's really strong. So it can withstand quite a bit of pressure, compression, torque, twisting, and so when it ruptures, it does take a while for it to heal because of its lack of vascularity. So that was the dense connective tissue. Now we're looking at the irregular. Quite a difference, right? Very much irregular. Okay, now it is densely packed collagenous fibers, but you'll notice that they're running in random directions, and there's also not as much ground space or ground substance as in loose connective tissue. But there's just a little bit more, but not as much. So you can have a little bit more vascularity going through there. And there's a few visible cells. So you'll find this in the deeper portion of the dermis, or the skin. It capsules around things like your liver, your kidney, your spleen, and even bone. So this has very much a protective function to it. Okay, and it withstands a lot of stress, and it can withstand stress in unpredictable directions. So this is irregular dense connective tissue. Now let's take a look at cartilage. Now cartilage has three different types of cartilage. We have hyaline cartilage, elastic, and fibrocartilage. So let's look at hyaline first. Hyaline, you'll notice, it's kind of a clear glossy matrix. It's often stained light blue or pink in tissue sections. Okay, your collagenous fibers aren't really that visible because it looks so clear, but there's a lot of chondrocytes. They're enclosed in lacunae. So lacunae, think of the word like lake. It's like a body of water that is enclosed. So you can kind of see the cells that are enclosed. Those are lacunae. Okay, and then your chondrocytes are located inside of those, with those blue. Remember, a chondrocyte is a cell that is basically producing this type of cartilage. Okay, and they're often, and as you can see here, they're in small clusters. Okay, and some of the areas where you will find this is in joints. Okay, it eases joint movements, allows airway opening during respiration. So there is some flexibility to this. It is also, this is the precursor to bone. So when your body is developing, when you're an infant, you're basically, especially in the womb, you're mostly cartilage. And then when you come out, when you're a baby, you're a mixture of cartilage and bone, but the bone is still soft and very malleable. Okay, and then that cartilage that your bone is eventually gets completely replaced. It ossifies and becomes bone. So that's hyaline cartilage. All right, now let's take a look at elastic cartilage. So the microscopic appearance for elastic cartilage, you see the elastic fibers. They kind of form a web-like mesh amid lacunae. So you can kind of see the lacunae, if you remember from the hyaline cartilage. It also always is covered by pericardium. Okay, so here you have a substance that is very flexible and elastic and provides support. So one of the places you'll find this is on your external ear. So if you grab your ear, you'll notice that your ear is very elastic and very stretchy and very tough, and very much flexible. And that's where that's one of the locations where you have elastic cartilage. Okay. Now actually, let me take a step back real quick, because I don't know if I told you where your hyaline cartilage, one of the areas. Now I did say that hyaline cartilage is replaced by bone, but some of the locations for hyaline cartilage is on the airway. Okay, so that the airway, it expands and it comes back, so it allows for some flexibility. Your vocal cords is made out of hyaline cartilage. Okay, so again, as you know, your vocal cords are constantly stretching and relaxing. So this material is very strong, but it's also very flexible. Okay, likewise with your elastic, but elastic is found in different areas. All right, and now finally we're looking at the fibrocartilage. Fibrocartilage, you'll notice that there's parallel collagen fibers that are similar to a tendon, but not quite as dense. And you'll notice that there's also a lot more nuclei there. So there's rows of chondrocytes in the lacunae. Okay. And one of the areas where you'll find this is in the pubic symphysis, which is the part of the pelvis where it's fused together. Okay, in between your vertebral disc. Okay, so it separates bones from the vertebral column. Okay, so it pads and allows for shock absorption in the knee joints at points where tendons insert into bones. So this stuff is very, very strong and very durable. Okay, fibrocartilage. Okay, so it resists compression, absorbs shock. It's often transitional tissue between dense connective tissue and hyaline cartilage. So again, this is like the cement or the nails of the house, if you will. This is fibrocartilage. Okay. So at this point, I just want to take a quick pause and just remind you of the three different types of connective tissue. We have loose connective, dense connective, and cartilage. And yes, loose and dense have 2 types, and cartilage has 3 types. All right, so finally we're going to take a look at well, not finally, but the last two are bone. Now, we're not going to spend a lot of time on bone and blood because, like I said, there's chapters that are completely dedicated to this. So this is a calcified matrix, and there's concentric circles. So as you look at the slide, let me back up. As you look at the slide, you can see that there's different concentric circles. Now, all the stuff that you're seeing, that's on the lighter color, that's calcified bone. Okay, so that's calcium phosphate. This stuff is stronger than concrete even. Okay, so you see the different concentric circles around the canals. So you see the canals, and then there's concentric circles. Now, in those concentric circles, you see what's called osteocytes. Okay, so osteocytes are cells that produce the bone, basically. Okay? And then in the blood, you have what's called erythrocytes. Erythrocytes are essentially, they kind of look like a donut there, a red donut. That's the red blood cells. That's the part of the blood that carries oxygen to the different vessels and carbon dioxide back to the lungs. And you also have what's called neutrophils and lymphocytes. These have immune functions. They have immunity functions where they look for pathogens and kill any bacteria or viruses or what have you that are in the body or in the blood. So that is the five connective tissues that we have. We have loose connective, dense connective, cartilage, bone, and blood. Keep in mind, again, this is stuff that you want to keep in mind throughout the week. You want to keep looking at slides and be able to differentiate the different characteristics and locations of each of these types of connective tissue. This is the building material, if you will, of the human body. Then there's 5 that we discussed in this video. So that does it for connective tissue. Thanks for watching. Good luck in your studying.